All right, welcome back, everyone, to the deep dive. We're diving into a concept today that's pretty cool. It's functions that don't just do stuff, they give you back an answer or a result or even like a whole item. Imagine a tool, right? You use it, and it not only finishes the job, but also like hands you the finished piece. And listeners, I know you've been getting really good with lists and maybe even organizing shapes with groups. Well, today builds right on that.
Yeah. It's like you see how lists can hold multiple things and how to work with them. Now we're going to look at how functions can not just process that kind of data, but actually return it back to you so you can use it in other parts of your code. It's a huge part of making your programs more organized and reusable.
Okay, how about a scenario? Imagine you're making like a simple drawing program, and every time you click, you want to draw a circle, but each one with a totally random color. How would you tell the computer to pick a color for you?
Well, that's where a function that returns a random color comes in. It does all the work behind the scenes to pick the color and then gives it back to you so you can use it to fill your circle.
Right. And that's exactly what we're exploring today. We'll be looking at some super clear examples of how these types of functions are written. But even more important, why they are such a powerful tool, especially with lists of things like colors or even groups of shapes on your screen.
The goal is to make sure you understand how to make these helpful functions and see their real value. They can make your code way more organized and dynamic, especially for folks who are starting to get comfortable with lists and groups.
So this idea of a function giving us back a random color, how does that actually look in code? Our source today gives a great first example. It's a function called getRandomColor. And the first thing it does is make a list of colors: red, orange, yellow, green, blue. Looks pretty familiar, right? Just a normal list.
Absolutely. That's our set of choices right there on that list.
Okay.
Now, the function then uses something called choice. It's a built-in tool that Python gives us, really handy for picking one item randomly from a list.
So it's like a shortcut. We don't have to write all the code to figure out how to choose something randomly.
Exactly. And inside our getRandomColor function, the line color called choice colors is doing just that. Randomly picking one of those 5 colors and saving it to a variable called color.
Okay, I'm with you so far. Now here's where it gets interesting. The next line is return color. What's going on with that return statement?
That return is the key. That's how the function sends the chosen color, which is stored in that color variable, back to the part of the code that originally asked for it. It's basically saying, hey, I did the work, picked a random color, and here it is for you to use. This idea of a function actually giving something back, it's super important in building more complex programs.
Okay, and we can see that in action right below in the on-mouse press example. The line says color, get random color. So when you click the mouse, this line calls our getRandomColor function, right?
Right. The function does its thing, picks a color, and then returns that color. And then, bam, that returned color is stored in the color variable within our on-mouse press part of the code, which then sets the fill color of the circle you're drawing.
Oh, cool. So each time you click, you get a circle with a different color picked randomly from that list. And it all happens because of that return statement sending the color back.
Exactly. And there's a note here that's important. If a function doesn't have a return statement at all, Python automatically returns a special value called none. It's like the tool did the job, but forgot to give you the result.
Huh. So you could have a function that does some stuff, but if it doesn't have that return statement, you can't really use the result directly.
That's right. And when you try to use none as if it were a real value, like a color, things can get a little wonky.
Makes sense. Okay, there's a checkpoint one here, kind of like a little quiz. It says, what happens if we delete that return color line from our getRandomColor function? The options are, the code won't run, it runs the same, it crashes when you press the mouse, or it runs but the circles have no fill. What do you think?
I think it's the last one. The code runs, but the random color is always none, so each circle's fill is empty. The function still runs, it makes the list, it even picks a color, but without that return statement, it doesn't send it back. So on mouse press gets none when it tries to use the result of getRandomColor. And filling a circle with none, well, you get no fill.
Makes sense. It's like the function is choosing a color but forgetting to actually give it to us to use. Okay, let's dig into why these helper functions that return values are so helpful. I mean, in that first example, we could have just put that color list and the choice function directly inside the on-mouse press, right? Why even bother with making a whole separate getRandomColor function?
Yeah.
Is it just about organization?
It's about organization, sure, but it's much more than that.
Right.
Think about it. By having getRandomColor return a value, You create this little self-contained unit of code. It's like a mini program within your program. Makes your code easier to understand, easier to test.
Yeah, having get random color keeps on mouse press from getting too cluttered, right? But what about reusability? How does returning a value make things more reusable?
Ah, that's where it gets really powerful. Look at the returning values demo, #3 example. Now, it's not just circles on mouse clicks. It also has a big star that changes to a random color when you press a key.
Hmm.
And check it out, the on-key press part of the code also calls getRandomColor.
So we're using that same function in two different places.
Exactly. Because the logic for getting a random color is in a separate function that returns the color, we can use it anywhere we want that random color, without having to write the same code over and over again.
Oh, I see. It's like building a tool you can use in multiple places.
And it makes updating your code a breeze. Let's say you want to change how the random color is generated. Instead of picking from our list of 5, maybe you want to generate completely random RGB values, to get millions of color possibilities, like in this example. You only have to change the code inside the getRandomColor function.
And both the circles and the star would use that new color generation method.
Absolutely. It's a huge time saver and makes changing your program so much easier. It also ties into checkpoint 2. It asks, which is not an advantage of using helper functions. One option says, helper functions make your code run faster. What do you think?
Well, I don't think breaking code into functions would magically make it run faster. It might even be a tiny bit slower because there's that extra step of calling the function, right?
Exactly. While they're amazing for organization, they don't inherently make your code run faster. The big wins are cleaner code, reusability, descriptive function names, and making changes in one place that affect multiple parts of your program.
Gotcha. Helper functions make our code smarter and easier to manage, not necessarily faster. Now, the source goes on to using multiple returns, and I gotta say, that sounds intriguing. Can a function actually return different things at different times?
It can. A function can actually have more than one return statement, like the isNearCenter XY function. This takes in 2 pieces of information, the x and y coordinates, and gives back a single piece of information, whether or not it's near the center. True or false?
So, isNearCenter XY takes an x and a y coordinate and then does what exactly?
Well, it checks if that point is within a certain distance from the center of the canvas.
Yeah.
In this case, 50 pixels from 200 to 200.
I see. There's an if condition using the distance function. So distance calculates how far apart 2 points are.
Yep. And if that distance is less than 50, meaning the x and y are near the center, the function immediately does a return. True. Here's the important part. As soon as a return statement runs, the function stops. It doesn't bother checking any other conditions or do anything else.
So it's like a shortcut. If it finds the point is near the center, it immediately returns true and doesn't even look at the else part.
Exactly. But if that condition in the if statement is false, meaning the point is not near the center, then the program moves on to the else block and does a return. False.
Oh, okay. So there are 2 possible exits for the function.
Right. Each one returning a different value depending on whether those input coordinates are near the center or not. And it's being used right here in this on-mouse move example. As you move the mouse, isNearCenter gets called, and the color of this dot changes. Green if it returns true, orange if it's false.
Neat. It's like the function is constantly giving us a yes or no about the mouse's position.
Precisely. That note is key to remember, though. Once a return statement happens, the function's done. No more code in that function runs.
All right, so far we've seen functions return simple values like colors or true and false. But get this, the source says a function can even return a whole shape. How does that work? Can a function give back something like a circle or a rectangle?
It can. The main idea is still the same. A function can return any kind of value, even complex ones like shapes, or in our example, a whole group. Remember groups?
Yeah, we've used groups to keep shapes together, like a bunch of circles or squares that make up one bigger object.
Exactly. Now check out this returning a shape demo. We've got this labels group. It's got 4 individual label shapes inside, each one showing a letter, R, O, S, and E. The getLabel function is set up to find a specific label within this group based on a key that we give it.
So this function gets a key, I guess that would be one of the letters, right? And then somehow it finds the matching label in the group and gives it back.
That's it. Inside the function, it loops through all the children of the labels group. And labels.children is essentially a list of all the shapes inside that group.
Got it. So it's going through each shape, one by one.
Right. For each label in that list, it checks if its value, which is the letter it displays, matches the key that was passed in.
And what happens when it finds a match?
If it finds a match, it immediately does return label. It doesn't just return true or false. It gives you back that entire label object itself. And just like before, the function stops right there.
Okay, I think I get that. But what if it goes through all the labels and can't find one that matches the key?
If it finishes the loop and no match, the code does a return. None. It basically says, I looked everywhere, but couldn't find what you asked for.
And we see this in action in the onKeyPress example, right? If you press R, the getLabel function runs, finds the R label, and returns that whole label object.
Yep. And then the code checks if the return label is not none. None meaning it found a match. If it did, it changes that label's color to red.
That's pretty cool. So we can use a function to actually find an object in a group and then do something with it, like change its color.
Exactly. And this takes us to checkpoint 3, where the source shows us a common mistake when writing functions with loops and multiple return statements. There's an incorrect version of getLabel, where the return none is inside the else block of the if statement. Do you see what's wrong with that?
Let me think. So in this wrong version, it checks if the label's value matches the key. If it does, great, return the label. But if it doesn't match, it immediately returns none. Doesn't that mean it only ever checked the first label?
That's exactly it. The right answer is, the code runs, but only the first label can match, so only R can turn red. If you press R, the first label matches, it returns that label and stops. All good. But if you press, say, O, it checks the first label, R doesn't match, and immediately returns none. It never even gets to check the other labels.
That's a big difference. That misplaced return, none really messes things up.
Right. It really reinforces that once a return statement happens, the function's done.
Wow, this has been a great deep dive into functions that return values. We've seen how they can give back simple things like colors or true and false, and even complex stuff like entire shapes, and it's all thanks to that return statement.
And we've seen why they're so useful. Cleaner code, reusable bits of logic, and much easier to modify things later on. Plus, really understanding how those multiple return statements work, especially when you've got loops going through lists or the children of a group, that's essential for writing functions that behave exactly the way you want them to.
Okay, so key takeaways. Functions can definitely return values, and you can use those return values in other parts of your code. Helper functions that return values are a great way to keep your code organized and easier to change later. And you can even return things like shapes, which is super helpful when you're working with groups and want to manipulate specific shapes within them.
And thinking about your experience with lists and groups, you can start to see how functions can be these powerful tools for working with collections of data in more interesting ways.
So a final thought to leave you with, now that you know functions can return values, what other kinds of information or objects do you think would be useful to get back from a function? What kind of tools could you build? What could you do with lists? It gets really exciting when you start thinking about functions as not just doing things, but giving you back specific pieces of information to work with.
We encourage you to play around. Write some functions of your own that return values. See what happens. Maybe a function that takes a list of numbers and returns the average, or a function that takes a group of shapes and returns the one closest to your mouse. Get creative and see what you can build.
That's all we have time for today, folks. Until next time, happy coding.